My name is Mboti Darwin Vera. My group members are Nathaniel and Lawrence. Today I will be discussing the production of styrene by catalyst dehydration of ethyl benzene, a crucial monomer in the plastic industry. So this presentation will cover a breadth of potholes from packaging to construction. So some of our outlines, we'll be looking at introduction to the styrene production, the broad importance of styrene, our process flow diagram, layout units on site, computer needs, software part of the plant, and then our network connect. Introduction to the main chemical process. Styrene, also known as a vinyl benzene, is an organic compound with a chemical formula C8H8. Chemically, styrene consists of a benzene ring substituted with a vinyl group, making it a reactive aromatic hydrocarbon. This structure allows styrene to undergo polymerization easily, forming long-chain molecules that are the building blocks for a wide range of synthetic materials. The reaction takes place in a reactor vessel under controlled conditions to optimize yield and minimize byproducts. Physical and chemical properties of styrene production. So the styrene has a molecular formula of C8H8. Its molecular weight is 104.15 grams per mole. Its boiling point is 145 degrees Celsius, and it has its density to be 0.91 grams per centimeter cube at 20 degrees Celsius. It's very soluble in water and also soluble in organic solvents like ethanol, ether, and benzene, and it is very reactive. So we have some importance of styrene. And styrene is a vital organic compound widely used in the manufacture of plastic, resins, and synthetic materials. So it is a colorless, oily liquid with a sweet aromatic odor and serves as a key monomer in the production of polystyrene and various copolymers. It's also used in the production of styrofoam and our mattresses. So industrial importance of styrene. Styrene is a cornerstone of the petrochemical industry. It is primarily used to produce polystyrene, acrylonitrile butadiene styrene, styrene butadiene rubber, and unsaturated polyester resin. Global demand for styrene exceeds 30 million tons annually, reflecting its widespread application in packaging, construction, automotive, and electronics. The global styrene market is expected to continue growing in the coming years, driven by increasing demand for emerging markets. So this is our process flow diagram, and this process flow diagram shows how raw materials are being processed into a finished product. So the process flow diagram provides a visual representation of the process, showing the major equipment and streams. It's a useful tool for understanding the process and identifying potential areas for the improvement. So some steps are involved in the production, and some of these steps are the alkylation of benzene with ethylene. So ethyl benzene is produced through the alkylation of benzene with ethylene. This reaction is typically characterized by an acid catalyst. The next point is dehydrogenation of ethyl benzene to styrene. So ethyl benzene is then dehydrogenated to form styrene. This reaction is typically carried out over a proprietary catalyst. We also have product separation and purification. The styrene product is then separated and purified through a series of distillation columns. This step is crucial to produce a high quality of the styrene. And our last point for this chapter is recycling and energy integration. Our plant looks like on the site. So this is how our plant looks like, and this is how every component is arranged, everything is arranged on the site for the effective running of the styrene production plant. So we have some of the things that are the vital things that can be found on the site, which are our control rooms, and this is the nerve center of the plant. I will say it is the headquarters because it houses the distributed control systems, human machinery interface, and other monitoring equipment. Administrative building. This unit accommodates management, human resources, and other administrative staff. The next point that can be seen on the site is a laboratory quality control lab, essential for the quality assurance of raw materials in process streams and final products. We have a maintenance workshop where maintenance personnel repair and calibrate equipment, a warehouse for storing our materials, a utility block which houses essential utilities like steam generation boilers, cooler towers, compressed air systems, and water treatment plants. Safety and emergency response facilities include the fire suppression system, emergency showers, first aid stations, and potentially an on-site clinic. Waste treatment plant. So this is responsible for treating industrial wastewater and managing solid waste generated by the plant to comply with the environmental regulations. So we also have a tank farm, this area is dedicated to the storage of large quantities of feedstock, intermediate and final products. These areas require robust monitoring for level, temperature, and leakage detection. Our next point is computer needs, and this some of these under this is the input devices. So the computer hardware needs of a styrene manufacturing plant are extensive, ranging from process control to administrative functions. Emphasis is placed on robust and reliable systems capable of operating 24/7 in a potentially harsh industrial environment. So input devices are crucial for gathering real-time data from the plant floor, enabling monitoring, control, and safety. Some of these input devices are our temperature sensors, our pressure sensors, our flame sensors, and then our vibration sensors. So all these things are present on the site to be able to detect any malfunction so that explosion can be minimized on the styrene production. So you have some software needs of the plant. So these software needs help the plant to function effectively. So some of these are process simulation software, advanced process control, manufacturing executive systems, expertise resource planning, and then laboratory information management system. So we have our network connectivity. So the network connectivity of styrene production is critical to ensuring the effective and safe production of high quality styrene by leveraging advanced technologies and systems. Manufacturers can optimize their process, reduce costs, and improve customer satisfaction. So a hybrid approach combining both wired and wireless is typically adopted in the chemical manufacturing plant due to the varying requirements of different areas and devices. And then we have reliability and stability. Wired connections offer superior reliability, stability, and consistent bandwidth, which are critical for real-time process control data. So as security. Wired networks are generally more secure than wireless networks as they are less susceptible to external interceptions and unauthorized access. They have the high bandwidth and low latency, essential for large data transfer and applications requiring immediate response times. Then our last point over here is immunity to interference. So less susceptible to electromagnetic interference that can be prevalent in the industrial environment from motors, pumps, and other electrical components. So the electrical connectivity talks about how everything on the styrene production farm can work effectively, leading to the effective running of our styrene production. In conclusion, the production of styrene is a complex process that requires careful attention to technical details, safety, and environmental considerations. As the demand for styrene continues to grow, it's essential for manufacturers to prioritize sustainability and innovation to meet the needs of a rapidly changing world. This here comes to the end of our presentation.